Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 9.1, which is going to deal with properties of parallelograms. Now, module 9 is going to shift our focus from triangles to quadrilaterals, which means instead of dealing with a three-sided shape, we're going to be moving to four-sided shapes. Now, today and tomorrow, we're going to specifically take a look at parallelograms, which is just one of the different forms of quadrilaterals, and we'll take a look at a few more throughout the module. So, for today, we are specifically looking at properties of parallelograms. Now, today we have one learning goal, and our learning goal for today is that you will be able to use the properties of parallelograms to find measurements, whether it be angle measures, side lengths, segment lengths, diagonal measures, whatever it may be. We're going to use the properties of parallelograms to help us solve those. So, let's get into talking about what a parallelogram is. First of all, a quadrilateral is a polygon with four sides. So whenever you hear the phrase quadrilateral, that just means a four-sided shape. Now, a parallelogram is a quadrilateral that has two pairs of parallel sides. Now we're going to get into the properties of parallelograms here in a second, but know that a standard basic definition of a parallelogram is that it has two pairs of parallel sides. So that's kind of the key thing to keep in mind. Alright, so now that we have talked about what a parallelogram is, it's a quadrilateral that has two pairs of parallel sides. We're going to start to look at our different theorems or different properties of a parallelogram. Now before we do that, just real quick, a segment that connects two non-consecutive vertices of a polygon is a diagonal. And we're going to take a look at diagonals and the property from parallelograms here at the end. Okay, so first theorem. And I'm going to go ahead and move this up so we can just focus on the theorems. Alright, our first theorem is going to state if a quadrilateral is a parallelogram, so if we have a parallelogram, then its opposite sides are congruent. So if we're looking at our parallelogram here, okay, if we have a parallelogram, which we do, because opposite sides are parallel to each other, then the opposite sides are congruent, meaning this side is the same measure as that side, and this side is the same measure as this side. So opposite sides are congruent to each other. If this is 12 units long, that means this is 12 units long. If this is 7 units long, this is 7 units long. So know that opposite sides in a parallelogram are congruent to each other, meaning they are the same measure. Alright, next one states that if we have a quadrilateral and it is a parallelogram, so if a quadrilateral is a parallelogram, then its opposite angles are congruent. So just like opposite sides are congruent, for parallelogram, opposite angles are also congruent, meaning this angle is congruent to this angle, and this angle is congruent to this one. That means that they have the same measure. So if this one is 50 degrees, that means this is 50. If this is 130, that means this is also 130. So parallelograms. Opposite sides and opposite angles are congruent to each other. Now, to kind of build off of this theorem, there's another property that pops up, and that is that consecutive angles add up to be 180 degrees. So what are consecutive angles? Consecutive angles are angles that are next to each other, so these two would be considered a consecutive angle. So if this is 130 degrees, that means this has to be 50 because they have to add up to be 180. So if you know this angle and I wanted you to tell me the measure of this, you would take this number and you would do 180 minus this number, and that would give you the measure of this. And then you know opposite angles are congruent. Now, these two are consecutive, these two are consecutive, these two are consecutive, and these two are also consecutive. All right, our last theorem, and this is where diagonals come into play, states if a quadrilateral is a parallelogram, then its diagonals bisect each other. That means they're going to cross and they're going to cut each other in half. So this diagonal is going to cut this diagonal in half. And this diagonal is going to cut this one in half. Meaning that this part is congruent to this part, and this part is congruent to this part. So these two sections are congruent to each other, and these two sections are congruent to each other. So those are the 4 different things and properties to talk about with parallelograms. So opposite sides are congruent, opposite angles are congruent, consecutive angles add up to be 180, and the diagonals bisect each other. So we're going to use these 4 different properties for parallelograms, the quadrilaterals that have 2 pairs of parallel sides, to answer our questions for example 1 and example 2. So with that said, let's go ahead and get into our first example for today and utilizing some of these properties. Okay, example 1 states, find the measurement indicated from each parallelogram. So it's either going to be an angle measure or a side length, and we need to use the properties that we just talked about to help us figure them out. So if we look at A, we have the quadrilateral WXYZ, and they tell us that angle Z is 82 degrees, and they want us to figure out what the measure of angle X is. So we want to figure out what the measure of angle X is, and they also tell me this angle Z. How are these two angles related? Are they consecutive, or are they opposite of each other? They are opposite. They're not consecutive because they're not next to each other. These would be consecutive. These would be consecutive. These ones and these ones. But they're opposite of each other, so that means they're the same measure. So if Z is 82, that means X is also 82. So that means my answer is the measure of angle X is 82 degrees. And that's our answer for example 1A. All right, next, if we look at B, so we again have a quadrilateral WXYZ. They tell us that angle W is 108 degrees, and they want us to figure out the measure of angle X. So W is 108 degrees, and we need to figure out what X is. So how do these two angles relate? Are they consecutive, or are they opposite of each other? They are consecutive because they're next to each other and they're not opposite. So because they are next to each other, that means that they are consecutive, so they have to add up to be 180 degrees. So to figure out the measure of X, we're going to take 180 and we're going to subtract it by 108. So if we do 180 minus 108, we end up with 72 degrees, which means that the measure of angle X would be 72 degrees. And that is going to be my answer for part B. All right, so that is how we're going to do parts A and B. We just have left parts C and D. Now for part C, this one is going to deal with side lengths. And again, we have, instead this time, we have VWXY for our quadrilateral. They tell me that the side WX is 16, and they want me to figure out what the measure of VY is. Now, these two side lengths are opposite of each other, so what do we know about opposite side lengths? Okay, first theorem stated that opposite sides are congruent. So if WX is 16, it means VY is also 16. So my answer for part C is going to be 16 units long. All right, then for D, let's just run through D real quick. So we have QRST as our quadrilateral. They tell me that angle Q is 95 degrees, and they want me to figure out the measure of angle R. So for angles Q and R, are these opposite or are they consecutive? Okay, they are consecutive because they're next to each other. So because they're not opposite of each other, they're not congruent. And because they are consecutive, that means that they add up to be 180 degrees. So to figure out R, we're going to take 180 and we're going to subtract it by 95. When we do 180 minus 95, we get 85 degrees. So that means the measure of angle R is 85 degrees. And that is my answer for part D. And that is how we do example 1. So if they ask you to find the measure of a side length, remember opposite sides are congruent. For angle measures, opposite angles are congruent, and consecutive angles add up to be 180 degrees. All right, so that is example 1. Let's move on to example 2, our final example for the day, on the back side. Now, the next page is all about example 2, and we're going to up the ante and add in x or y into the problem. So, for example 2, part A, says ABCD is a parallelogram, and they want us to find each measure. So, if we look at our parallelogram, ABCD, right here, if you notice, we have y for both of these angles, and we have x involved for both of these side lengths. So, that means we need to go through and figure out what x equals, and we also need to go through and figure out what y equals, and then we can figure out measure of side lengths or angles. So first, let's focus on x, because that's the usual starting point. For x, we have this 5x plus 19, and we also have 7x. Now, both of these relate to side lengths, BC and AD, and by looking at our diagram, they are opposite of each other, so that means they are congruent. If these side lengths are congruent to each other, that means that they're equal. So we're going to take this 5x plus 19 and set it equal to 7x. So I now have 5x plus 19 equals 7x. All we have to do is just go through and solve for x. So it means I'm going to subtract the 5x to the 7x. So that gives me 19 equals 2x. And then having 19 equals 2x, to get the x by itself, we're just going to divide this 2 out and over to the 19. So if I go ahead and divide 2 to both sides, 19 divided by 2 is going to give me 9.5. So I now know that x equals 9.5. Now, if we wanted to know the measure of side length either BC or AD, all we need to do is just plug 9.5 back in to one of these expressions. So let's say I take this 7x. If I do 7 times 9.5, and use our calculator, 7 times 9.5 gives us 66.5. So that means BC and AD are equal to each other, and that they have the measure of 66.5. And that is our answer for BC and AD. Now, we're not completely done with this problem because we also have angle measures for B and D to figure out. Now, for the angle measures for B and D, okay, we're dealing with these two expressions here, the 6y plus 5 and the 8y minus 17. Because these two angles are opposite of each other, that means that they are equal to each other. If they were consecutive and next to each other, it means that they would add up to be 180. But because they're opposite of each other, they're equal to one another. So we're going to take both of those expressions, the 6y plus 5, and set it equal to the 8y minus 17. So now that I have my equation set up, we just have to go through and solve for y. I'm going to move the 6y to the right. I'm going to subtract it over. So if we do 8y minus 6y, 8 minus 6 is 2. So we end up with 5 equals 2y minus 17. I then want to move the 17 to the left because it's minus 17. We're going to add 17. So we're going to do 5 plus 17, which is going to give us 22. So I now have 22 equals 2y. Now, all I have to do for my last step is just go through and divide the 2 to both sides to figure out what y equals. So if I divide 2 to both sides, 22 divided by 2 is going to give me 11 for y. So I now know what y equals. So to figure out what the measure of angle B and D are, we're just going to take this 11 and we're going to plug it into one of these two expressions. Doesn't matter which one. I'm going to take the 6y plus 5. So if we do 6 times 11 plus 5, and then we use our calculator. So if we do 6 times 11, we get 66, and then plus 5 is going to give us 71. So that means I know that the measure of angle B and the measure of angle D are the same measure because they're opposite, and that they are 71 degrees. And that is our answer for example 2, part A. Now, when you get to the homework, it might break this up into a couple different questions than necessarily all at once. But know that opposite sides are congruent, so you're going to set them equal to each other. Opposite angles are congruent, so you set them equal to each other. And consecutive angles are going to add up to be 180 degrees. Alright, so that is part A. Next, let's go ahead and move on to part B for our next example. Alright, so I'm going to move this on up, and let's take a look at B. So for B, we have PQRS is a parallelogram, and they want us to find each measure. And in this one, they tell us which ones they want us to find, and that is QR and PR. So they want us to figure out the measure of QR and the measure of PR. So we will go through and do that right now. Alright, if we first look at QR, so QR is going to deal with this side length right here, and they tell us that QR is 3z minus 4. Now, the thing that we know about side lengths is that opposite sides in a parallelogram are congruent. So if I know this is 3z minus 4, and they tell me that PS, which is the side opposite of QR, this 2z plus 4, it means both of these expressions should equal each other. So we're going to take the fact that QR is congruent to PS, and we're going to set both of these expressions equal to each other. So to figure out z, that's what we're going to do first. So we're going to take 3z minus 4 from QR, and then 2z plus 4 from PS. So 2z plus 4. And then we're just going to go through and solve for z. So I'm going to move this 2z to the left because it's positive 2z. That means I'm going to subtract it. So 3 minus 2 is just 1. So that means I have z minus 4 equals 4. And then to solve for z, because this is minus 4, we're going to do the opposite, which is add. So 4 plus 4 gives me 8. So z equals 8. Now, knowing that z is 8 is great, but it doesn't tell me what I want to know for QR. So to figure out QR, we're going to take this 8 and we're going to plug it in for z. So we're going to do 3 times 8 minus 4. 3 times 8 is 24. So we have 24 minus 4. And 24 minus 4 is going to give us 20. So that means QR equals 20. And that is my answer for QR for part B. Okay, next we have to figure out what the measure of PR is, and PR is going to be a diagonal through the parallelogram. And the thing that we know about diagonals from our theorems is that diagonals bisect each other. So this diagonal QS bisects PR. So that means this segment is congruent to this segment. So those two parts, these two expressions, are congruent to each other, which means they are equal to each other. So what we're going to do is we're going to figure out what x equals by setting these two equal to each other. And then we're going to use that value of x to plug it back in to solve. So let's first figure out x. Like I said, QS bisects PR. So it means PT and RT are the same measure. So we're going to take x plus 9 and we're going to set it equal to 4x minus 6. Alright, so all we have to do here is solve for x. So it means we're going to move this 1x to the right. Because it's positive, we're going to subtract it to this 4x. So 4x minus 1x, 4 minus 1 is 3. So I get 9 equals 3x minus 6. My next step, because this is minus 6, I need to move this to the other side because it's subtracting. Doing the opposite would be adding. So 9 plus 6 is 15. So I get 15 equals 3x. And then our last step is to just divide. So we're going to divide 3 to both sides, and 15 divided by 3 is going to give us 5. Now, knowing that x equals 5 is great, but that doesn't tell us the measure of PR. Now, PR is the entire diagonal right here. So this whole diagonal is PR, so that means PT plus RT equals PR. So this whole thing is these two parts added together. So we're going to take this x plus 9 plus 4x minus 6 to tell us what PR is. And we're going to plug 5 in for x. So we're going to do 5 plus 9 plus 4 times 5 minus 6. So I'm adding these two expressions together and plugging 5 back in. And all we're going to do is just use our calculator to go through and set this up. So 5 plus 9 plus 4 times 5 minus 6. And we end up with 28. So that means that 28 is the measure of PR. And that is going to be our answer for part B of example 2. So we have successfully gone through and found the measure of QR and then PR. All right, so before I wrap up for today, I do want to take a look at example 2C, just to kind of give us another problem to reference when you guys get to the homework. For example 2C, they tell us that PQRS is a parallelogram, and they want us to find each measure. So they want us to figure out the measure of RS, and they also want us to figure out what the measure of angle S and the measure of angle R is. So let's first focus on the side length. This RS is going to be this side length here, and they tell me it's x plus 3. And in a parallelogram, we know opposite sides are congruent. So it means I know that SR is congruent to PQ. So because opposite sides are congruent, these two sides are congruent to each other, meaning they're equal. So I can take 2x and I can set it equal to x plus 3. So if I go through and solve for x, I'm going to move this 1x over to the left. So 2x minus 1x, 2 minus 1 is 1. So it just becomes x equals 3. Now, knowing x equals 3 is great. That doesn't tell us the length of RS quite yet. So for RS, we know that it's x plus 3. And we're going to plug this value for x into our problem. So we get 3 plus 3, and 3 plus 3 is 6, which means the measure of RS is 6 units long. All right, next, they want us to figure out the measure of angle S. So for angle S, they tell me that it is 10n, and the only other thing I'm told in this diagram is that angle R is 8n. Now, for angle S and angle R, are these opposite angles or are they consecutive? They are consecutive angles because they're not opposite of each other, because they're next to each other. So because they're next to each other and they're consecutive, that means that they add up to be 180. So we're going to take 10n plus 8n, and then we're going to set it equal to 180. So all we need to do is solve for n. So 10n plus 8n, 10 plus 8 is 18. That equals 180. Then to solve for n, all we have to do is divide 18. And 180 divided by 18 is going to give us 10 for n. Now, knowing that n equals 10 is great, and that's going to get us to our answers for the measure of angle S and the measure of angle R. Now, for the measure of angle S, okay, I know it's 10n. So that means we're going to plug 10 in for n. So we're going to do 10 times 10. And 10 times 10 is going to give us 100. So that means the measure of angle S is 100 degrees. Now to figure out the measure of angle R, that expression is 8n. And they tell me that n is 10, or we found that n equals 10, so we're going to plug 10 in for n. So we're going to have 8 times 10, and 8 times 10 is going to give me 80. So that means that the measure of angle R is 80 degrees. And I have successfully found each measure they wanted me to find. Alright, so that is it for today's lesson on section 9.1. We have gone through and done every example and talked about different intricacies and things to look for. Be sure to reference the video again if you need help on the homework or my completed notes. As always, if you have any questions or need help, just let me know the next time you see me or via email. Otherwise, that is it for today. Thank you guys for listening and watching through the video. And I hope you have a great day, and I'll talk to you guys later. All right, bye.